Well, thank you very much, Bob, for that amazing introduction. As Bob said, I am currently working for the Kent Wildlife Trust, having returned home in a way. But what I'm going to talk to you about this evening is work that I did for a US organization called Island Conservation. And I'm going to talk to you about a couple of the projects that I did I worked with them between about 2007 for 10 years. And as Bob said, I was, very fortunate to actually travel around the world with them, doing some incredible conservation work. So I'm going to talk to you about islands and island biodiversity, which I know is actually quite an interest, quite a significant theme for DICE as well. Islands are extremely important to the world's biodiversity. I've worked on them most of my career. And we know that islands make up only about 5% of the Earth's land surface, but they actually hold about 1/5 of all plant, bird, and reptile species. And typically these are endemic species. They're animals and plants found nowhere else in the world because they're isolated on these islands. But islands are also very important for seabirds, also marine mammals and sea turtles. And while for much of the year, those animals might range thousands of kilometers across the open ocean, they need to return to these islands for breeding. And so islands are biodiversity hotspots. We know now that nearly 40% of all critically endangered species are on islands. That means that about 40% of all species on the brink of extinction are actually on less than 5% of the Earth's land area. We also know that if we look at the extinction rates, the data shows us that well over half of all extinctions have occurred on islands. And one of the primary threats to island species and which have been implicated in the extinctions of island species is invasive species. And we believe that probably more than 80%, up to 86% of extinctions of island species have been caused by invasive species. Primarily, we're talking about the introduced and invasive mammals. I've spent, as Bob said, most of my career working with threatened species on islands, all of which have been impacted in some way by invasive species. And I've just shown a few of them here. As Bob said, I started out working with the pink pigeon in Mauritius, and that was the focus of my PhD with DICE at Kent. And from there, I went on to work with critically endangered Hawaiian honeycreepers, which I know is also a DICE interest. I worked with the Maui parrotbill from the island of Maui and with the po'o'uli shown here in the bottom right. In fact, the po'o'uli is probably now extinct. My predecessor, who is also well known in DICE, and myself, we both worked with the last 3 known individuals. They have not been seen since the early 2000s. So these extinctions are not just historical, they are happening all the time. One of the species, or one of the taxa I worked with in the Caribbean, which I'll come to it in a bit, is the Cyclura rock iguanas. They're Caribbean endemic taxa. This is the recalled iguana from the Dominican Republic, and only a few thousand remain. So we know quite a lot about the impacts of invasive species on these islands and what has caused a lot of species extinctions. We know that invasive rats, for example, have reached more than 90% of islands worldwide, with devastating effects on particularly seabirds and also endemic species. We know that these invasive species, particularly the terrestrial mammals, have direct impacts on seabirds by predating eggs, chicks, adults. This is the same for invertebrates, for plants, and for reptiles and amphibians, some amphibians. And it's primarily because island species have largely evolved in the absence of predators. Species are commonly naive. You get the albatrosses, you can just walk right up to them, pick them up off the nest. And many species have developed traits that basically make them very susceptible to predation and also to overgrazing. You know, many plants on islands haven't developed thorns. They haven't developed the toxins in their leaves to make them unpalatable to grazers. And so they suffer from overgrazing. But we also know that invasive species have significant indirect effects as well on whole island ecosystems. And this is becoming increasingly better understood. For example, they disrupt nutrient cycles. The role of seabirds in cycling guano from sea to land has now been demonstrated not only in the temperate regions, it was primarily in some of the areas I used to work, but in the tropics as well. Given that seabird colonies are typically in their millions, hundreds of thousands of birds, the collapse and the decimation of these colonies by invasive predators leads to changes in the vegetation, and that leads on to changes in invertebrate fauna, soil fauna, ad infinitum, really. But there is hope. We know that we can prevent extinctions by removing invasive species from these islands. And you may have followed some of the media on various successes in the UK and internationally. There's been quite a few high-profile cases in the last 5-10 years. Invasive species eradication, particularly these terrestrial mammals, their removal from islands is a proven conservation management tool that we know restores habitat and enables plants and animals to recolonize them and to breed. The evidence shows us that to date, we know of more than 800 eradications of these invasive terrestrial mammals from islands around the world. And they've all been successful. There are a number that obviously that haven't, but those are 800 successful eradications. And this has benefited more than 200 species of birds, plants, reptiles, half of which were critically endangered, highly threatened. And nearly 200 of these have actually occurred since 2010. So the technique is becoming more widely applied, which can only benefit all these island species. So in 2007, I was lucky enough to join a US nonprofit organization called Island Conservation, whose sole mission was to prevent species extinctions by eradicating invasive species. Invasive terrestrial mammals was their primary technique that they had, by eradicating them from islands. And when I joined them, the organization had already had multiple successes, primarily in the Gulf of California, in Mexico. And at least by then, you know, more than 40 islands had been restored by removing these terrestrial mammals. Part of my training, in fact, I went there I don't think I was even employed for 2 weeks, and I was sent down to Mexico to join their fabulous Mexican team to successfully, which we did, eradicate rats from an island called San Pedro Martir in the middle of the Gulf of Mexico. And this was a fairly small island, 260 hectares. It was located slap bang in the middle of the Gulf of California, about 60 kilometers off the coast. So it was actually pretty remote. But this tiny little island supported some of the biggest populations of blue-footed boobies, which was one of our key conservation targets. Also some of the biggest populations of brown boobies and red-tailed tropic birds in the world. And this single action also protected 27 species of plants, 53 terrestrial birds, 4 reptiles species, some of which are endemic to the island, and an additional 30-odd seabird species. But that actually is another story. And I'm going to tell you instead about two other projects I was involved in while I worked for Island Conservation, and they were in very different parts of the world. In 2008, I joined a project to eradicate brown rats, or Norway rats as they're also known, from the aptly named Rat Island, and this is located in Alaska. This was a joint project between Island Conservation, the US Fish and Wildlife Service, which is the government agency mandated to manage the Aleutian Islands reserves, which Rat Island is one of those reserves, and with the US's Nature Conservancy. Rat Island, it's much bigger than San Pedro Martir. It's about 3,000 hectares and it's pretty rugged. And it's located in the Aleutian Island chain. And in actual fact, it's almost closer to Russia here than the United States. The island itself is one of several thousand rocks and islands that are protected by the Alaska Maritime National Wildlife Refuge that is managed by the US Fish and Wildlife Service. And this refuge covers about 1.5 million hectares and provides habitat for more than 10 million seabirds, plus some, of about 25, 26 different species. On the Aleutian Islands, there are also several endemic subspecies to terrestrial birds, and the islands are also absolutely critical habitat for seals, sea lions, and sea otters as well. However, in the early 2000s, when this project began, there were almost no seabirds were recorded as breeding on Rat Island. Historically, rats had been introduced to the island probably accidentally through shipwrecks, and we sort of can almost pinpoint it to the late 1700s. There were other invasives on the island before too. There was a suite of Arctic foxes that had been introduced as fur-bearing animals right across the Aleutian Islands, but these had already been eradicated from most of the islands by the time this project started, and the seabirds still weren't recolonizing. We know that seabirds in particular are vulnerable to rats because many of them are ground nesting. In the Aleutian Islands, many of them are burrow nesting. And we know that rats are significant predators of eggs and chicks. But in the Aleutians, they also kill adults of some of the smaller seabirds too. Some of their seabirds are really tiny, like the little auklets. There's a very large island next door to Rat Island called Kiska, which has hundreds of thousands of seabirds on it. It does have rats, but the volume of seabirds there almost sort of compensates for that. And field workers there found more than 150 rat-killed auklets in a single rat food cache. The island was once, Rat Island was once occupied by the Aleuts, the indigenous people who lived among the islands. And we know from their historical middens, from analysis of their middens, that various seabirds were relatively common on the island, including puffins, these little auklets, burrow nesting alcids, storm petrels, and more. And we also know that some of the smaller terrestrial bird species, like there's an endemic subspecies of song sparrow, were completely missing. We were recording them on offshore islands. They sort of marooned on these offshore islands, even smaller islands than Rat Island, and we suspect that those little smaller offshore islands were actually rat-free. So in September 2008, I joined 16 others from all of our partner organizations and Island Conservation to attempt to eradicate rats from Rat Island. The project had been 8 years in the planning, and I only joined a year before it was actually implemented, and I was involved in a lot of that last minute, that final years of planning, but it was essentially 8 years of planning in order to be able to implement this. And that planning involved obtaining at least 18 different permits, environmental assessments, various authorizations, and implementing multiple field trials and wildlife surveys. But when the day arrives, mounting an operation like this is largely about logistics. the methodology for eradicating rats from these large rugged islands has been well worked out, and it's been applied around the world for a couple of decades now, and it has proven to be successful. But the field implementation itself typically requires a pretty large team of people for a sustained length of time in a pretty remote site. Our Rat Island logistical operations involved 2 ships, a team of 17 plus people. We actually had an additional support ship towards the end of the project, 2 helicopters, a few tons of rat bait, 120 barrels of helicopter fuel and water for drinking, and supplies for up to 45 days. And these are all packed into 6 shipping containers at the beginning of an Alaskan winter, heading out to a remote island that was about 2,100 kilometers away from the nearest town. Our departure point was Homer, Alaska, up here. It's just off the side of the map there. And all the team spent a week of briefings, plus some week of briefings, trainings, and loading the ship and making sure we had all the gear ready. The original plans to get to Rat Island were that we were going to be flying to a closer island by a small plane called Adak, which had a small population and had an airstrip. However, these operations are typically beset with challenges from the day one. And in early August, there was a very sudden and unexpected eruption of a volcano along the chain called Casatochi. And it had never actually erupted in human history, and it spewed out that huge amounts of ash, and of course that stopped all flights. You can't fly an airplane through volcanic ash. So instead, we had to quickly revise our plans, and we left on the MV Reliance, which is a large, originally a fishing trawler, not designed to be taking very much of a crew. And most of the time, we were just sleeping on tables and benches and whatever we could find. And 6 days later, we arrived at Rat Island. So I mentioned that the technique for eradicating rats from these large, rugged offshore islands is well proven to be successful, and it was developed by the New Zealand Department of Conservation, and it continues to be refined. As we apply it to these different geographies outside of New Zealand, and as the technology becomes more sophisticated, the technique is improving all the time. But in essence, it uses an adapted agricultural technique with GPS and GIS technology integrated into an automatic spreader bucket, which applies a bespoke rodent pellet, a bait, at a consistent application rate across the terrain. But the skills and expertise in doing this, and the reason why these are this sort of approach is successful, it comes with the helicopter pilots. And the pilots themselves are rat eradication specialists. They can pilot in extreme terrain. They fly very low to the ground. But they also understand that if even a few square meters of terrain do not receive at least one pellet, then the whole operation could fail, the whole project could fail. So it's their knowledge of rat biology and their interpretation of the ground beneath them that makes these New Zealand pilots highly skilled and the best in the world. And most large-scale rat eradications using an aerial baiting technique have used these expert New Zealand pilots. As the helicopter flies across the island, it flies in a predefined and regular pattern, and real-time data is collected through the GPS and analysed on the ground to ensure that the bait application to the ground is consistent and spread evenly, and that there are no gaps in coverage. In this way, each rat on the island has access, it's exposed to at least one bait pellet, just one, which is adequate to ensure eradication success. And the field trials that go into these planning these operations prior to implementation enable us to determine the pellet density that's required to kill all the rats, but that will also have minimum impact on the environment. So one major risk that was fairly obvious to our success on Rat Island could have been the weather. We were heading out early Alaskan winter, and poor weather can really disrupt operations and run the risk of failure. However, someone blessed us with a 10-day window of just the most incredible weather, clear skies, balmy temperatures, sunny even, which in essence meant that our operations ran as smoothly as they could have done. And in actual fact, not wanting to miss that weather opportunity, we actually started the operations as soon as we got there virtually. And so at the same time, we were setting up our base camp while we were also trying to implement the operation, because the weather really was a potentially significant risk. So in the end, baiting the entire island only took us about 2 days. There is a repeat application 3 days later, the reason being that you get dominant rats eating the bait first. And if there isn't enough available for the subdominant or the juvenile rats, then your operation will fail. So the second application ensures that all rats actually eat the bait. And the remaining time that we have was spent, we have to bait some of the sensitive areas by hand, for example, some like interior lakes, and packing up all the supplies that we had, returning to the ship. And we also spent a lot of time monitoring rat activity and wildlife activity. We had to be careful of disturbance to things like the seal and sea lion colonies. But in essence, 10 days after arriving on the island, our job was done, and we had planned for 45 days. But we had on our radar a massive storm that was coming. So we decided to leave as soon as possible, else we could easily have been stuck there for another month. In actual fact, we did get stuck on our trip back. We had to offload at an interim island where we got stuck for about 5 days before this storm, while this storm passed. And only then could we actually get back to our base camp in Homer. So how do we know that we were successful? Well, the standard approach is to go back in a year or two and do a island-wide rat detection survey. And that was completed, and it was shown that the rat eradication was successful and the island was rat-free. But it's not just about getting rid of rats. The goal is to restore the island's biodiversity. And so a couple of subsequent surveys have been implemented. These are results from 5 years after the operation in 2013 that showed that several of the native and endemic bird species had increased significantly compared to our pre-eradication baseline assessments. And you have to remember that in actual fact, things like the song sparrows and snow bunting, there were 0 birds in pre-eradication assessments, and these were now being commonly seen across the island. These song sparrows had started nesting, and other terrestrial passerines like the longspur and the rosy finch were also increasing. So that was also evidence that the island was recovering. For the seabirds and the shorebirds in particular, the number of oyster catchers had increased 5-fold. Nesting oyster catchers had increased 5-fold. And nesting glaucous-winged gulls, in essence, had increased by more than 400%. Of particular interest to us was that in 2013, tufted puffins that had not been recorded on breeding on the island for decades was recorded, as was Leach's storm petrel. Leach's storm petrel is a small nocturnal burrow nesting and endangered seabird, and pretty difficult to monitor. But using sound recorders, we could detect this little bird across about, or courtship calls of this little bird across about 80% of the island. So overall, even the bird life species, the richness had increased. Several new species were recorded for the first time, including ravens, pelagic cormorant, snow goose, among others. But because of the relatively slow reproductive rates of seabirds, recolonization will take some time, but there are neighboring populations of seabirds on other islands that will help to do that. The ultimate sort of positive outcome of this project was that the Rat Island lost its name. It is no longer Rat Island, and it was renamed its original Aleut name, which is Hawedax. So in 2011, still with island conservation, I moved to the Caribbean, to the island of Puerto Rico, to help develop a similar program of work with invasive species and island restoration, and to implement a project on this island, which is called Desecheo, which lies about 17 kilometers offshore of Puerto Rico. For those of you who know the Caribbean, Puerto Rico is next door to the Dominican Republic, which of course is quite a big tourist destination these days. And Puerto Rico is actually under US administration. It's an incorporated territory. Desecheo Island itself is located there in the Mona Channel, which is a really deep marine channel, and also has another large island called Mona Island, which is also very significant for biodiversity. But having lived on tropical islands before, these lovely blue seas of Puerto Rico was a little bit more of my home habitat. And I didn't feel like I was at risk of death from cold if I fell into the sea like I would have done in Alaskan waters. So Desecheo Island is also a national wildlife refuge, like the Aleutian Islands, and also managed by the US Fish and Wildlife Service. And it was originally set aside as a wildlife reserve in 1912 in recognition of its wildlife value. But the introduction of several invasive species to the island, including rats, had led to a significant deterioration in the habitat and a virtual collapse of the seabird colonies. So when it was designated in the early 1900s, the island, and it's only 120 hectares, was home to thousands of breeding seabirds of at least 9 species. Estimates include up to 15,000 brown boobies, red-footed boobies at about 2,000, and the same number of these smaller seabirds such as noddies, bridle terns, sooty terns, and also the fabulous, magnificent frigate birds. But by the 1990s, pretty much all those species had disappeared. There are roosting magnificent frigate birds. There were a handful of bridle terns that were laying eggs. We didn't see chicks. And there were roosting brown boobies, but had not been recorded nesting. But in addition to the seabird colonies, Desecheo was also home to some pretty unique reptiles. There were 3 single island endemic. They're endemic just to that 120 hectare island. The little dwarf gecko here, the big ground lizard, the amoeba, and the anole. And a couple of native species, the skink in the bottom right-hand corner here, and the racer snake. And while several of these species are still relatively abundant, even with rats on the island, the skink and the racer were actually quite rare, and we only observed them a handful of times. In fact, during our field work in planning for this rat eradication, we documented scarring on both the racer and the lizards. That was a result of rat attacks, and this has been documented in other, particularly racers in the Caribbean since then. So in 2012, we once again mounted an operation to try and eradicate rats from this amazing island and to restore its seabird colonies and other wildlife. Once again, we partnered with the US Fish and Wildlife Service that managed the island as a nature reserve, and with other local government. The operation took, again, at least 4 years of planning. It was one of my first projects even before I moved to the Caribbean. And the actual implementation comprised more than 40 people from our partner groups and also other NGOs and contractors. And while the island's pretty small compared to Rat Island, it's extremely rugged. And there were large areas of the island that you just couldn't access on foot. So we once again recruited our New Zealand expert pilots to apply bait using the same technology that had been applied to Rat Island. One of the differences to the Rat Island project was that while on Desecheo, there were also very few birds resident on the island, but neither seabirds nor terrestrial birds, there were some abundant reptile populations which were surviving despite rats. There is little evidence that reptiles will either eat or be affected by the rat bait. And we did a number of trials to demonstrate the risk. However, because they were endemic species on the island, we took the precautionary approach, and we actually held a proportion of individuals in captivity on the island just in case of any significant mortality in the wild. And these were kept in captivity for several weeks after the last bait application. But as there were no impacts to wild populations, they were eventually released. And we implemented a pretty comprehensive monitoring program for these species, which in actual fact that work has been published. In addition, the smaller size and proximity to the mainland of Desecheo compared to Rat Island meant that we could actually keep a field team for longer on the island, and we also monitored a number of other aspects of the habitats and the rat ecology and biology, or the rat eradication process itself. We were able to monitor that for several weeks after the actual bait application. However, during a field trip in March 2013, this was 1 year after the application, the operation, we observed rats on the island. And when we recalled our remote cameras, which are used to help demonstrate wildlife recovery, and also potential rats on the island, when we looked at those, we actually found rats on those cameras in November 2012, which was 8 months after the bait operation. We did genetic testing of the rats, we collected samples pre-operations and post, and the populations are the same, which in essence told us we had failed to eradicate all the rats, and they had bred and re-emerged. Experience indicates that tropical rodent eradications have a generally lower success rate than temperate regions. And part of this is to do with rat biology and the habitat in the tropics. The existing methodology is designed to target your rats when they are most hungry. So that is when food supplies are lowest, but natural food supplies. But in a tropical system, there's generally a higher abundance of food anyway. And while there are seasonal fluctuations, there's always food for rats year round. In addition, on this island and on many other tropical islands, there is an abundance of native land crabs and other invertebrates, and we believe ants on this island particularly, that consume vast amounts of rat bait. This has been shown in other tropical eradications too. And even though these invertebrates, the rat bait doesn't affect them, in essence, it means there's less food for the rats, there's less bait for the rats. And so not all rats are being able to find bait. In addition, in tropical systems, rats have extended breeding seasons, and so they're able to re-emerge, repopulate a lot more quickly. However, we were particularly fortunate to have very strong support from our partners, from the US Fish and Wildlife Service and other local partners. And after some extensive reviews of the project by external experts, our own data analyses, and a significantly revised methodology to account for some of those issues we felt may have contributed to the failure, the US Fish and Wildlife Service endorsed the project for a second attempt. And we made a second attempt using the same general methodology, but with some revisions. We made that attempt in 2016, and this time we were successful. And in comparing the two operations, we further understood some of the issues and what might have happened, particularly the influence of weather and climate, which had caused the failure in 2012. In 2012, in the 6 months prior to the operation, we believe the island received more than 6 times the rainfall than it had done in 2016. And this was a regional phenomenon going on in the Caribbean. And it had probably led to a flush of vegetation and fruits and invertebrates, which the rats would have fed on in preference to rat bait. So while we have now a wonderfully rat-free island, the end goal, of course, is the restoration of the wildlife there. And seabird recolonization of an island post-eradication is significantly influenced by the proximity of other populations. And unfortunately, the Caribbean has seen a huge decline in seabird populations in the last 50 years or so. And this is no different for Puerto Rico. And while several seabird species have been recorded offshore of Puerto Rico and flying over the island, and some of them do roost on the island, most of the nesting populations of species we're interested in, like the red-footed boobies, for example, are either on the East Coast or are pretty rare elsewhere. So after I left Island Conservation, actually, this work was done by my colleagues. And they applied some social attraction techniques, which is a commonly used technique to assist in seabird colony re-establishment. And they applied some of these techniques to Desecheo with some quite interesting results. Although while it is still early days, one of the astounding results that we were very excited about was a record of an Audubon shearwater arriving at the island in response to playback of calls, which is also another social attraction technique you can use. And I don't know if you can see his little beak poking out behind the loudspeaker there, but he's obviously very interested. Audubon shearwater nests only in the Caribbean. It's a burrow nesting species, and so again, highly vulnerable to rat predation. Historically, there was a vast colony of Audubon shearwater on a neighbouring island, but that is, again, much reduced because of invasive species on that island too. And in actual fact, it had never been reported from Desecheo. We had had a couple of flybys late on during actually in 2012, when we did the rat eradication, the first one, we actually documented it there. But this is still an incredibly exciting result. And we really hope that it could become a safe haven for this species to nest in Puerto Rican waters. Another surprise outcome that was partially due to the rat eradication, but also partially due to the removal of other invasive species from Desecheo over the last 20 years or so, was the rapid appearance of this very endangered cactus. It's called Higo jumbo, and it's a night flowering cactus endemic to Puerto Rico, only known from 3 offshore islands, including Desecheo, and it's been extirpated from mainland Puerto Rico because of overbrowsing and intense, browsing by non-native grazers. It's a IUCN red listed species and is protected as an endangered species in the US. During our field surveys in 2009, we didn't find a single plant. But by 2013, we documented more than 70 individuals. And at the time, we believe these have grown from rootstock due to the relaxation of pressure from things like goats, which were being removed by our partners as a parallel project. But while that may well have contributed to their significantly to their resurgence, we do believe that the eradication of rats will continue to contribute to its rapid recovery across the island. The picture in the bottom right there shows a black rat eating one of these Ego jumbo cactus fruits on the adjacent island of Mona, which is another one of the other 3 offshore islands from which this species is present. So they will certainly have, had they been on Desecheo, they would certainly have had a major impact on seed survival. So with that, I hope that you have enjoyed my little journey. Thank you very much for listening. I would particularly like to thank Island Conservation for the incredible opportunities to be involved in these projects, and these are just a couple of ones that certainly I was involved in, and you know, only a couple of the incredible work that Island Conservation does all across the world, really. I'd also like to particularly thank friends and colleagues at the US Fish and Wildlife Service and in Puerto Rico, the Department of Natural Environmental Resources, without whom, you know, this work would not have been accomplished. Thank you, Bob, and thank you, Dice, for inviting me. And I would be happy to take some questions.